Oh, sorry. Sir, is it audible, sir? Sorry.
Yes, now
So,
it is
so-
now
sorry,
audible.
sorry. Yes, sir. So, very good afternoon, everyone. And sorry, my mic was muted. So, I'm going to handle a session on role of automation in construction projects. So these are the list of contents I'm going to deliver. That is, I'm going to start my presentation with the introduction about IoT in civil engineering and its application. Okay, and the main focus in this lecture is I'm going to deliver. I'm going to talk about drones and robotics in civil engineering. Okay, how drones play a vital role in especially the bridge inspection. Okay, so I'm going to explain about the case study, and another aspect of this lecture is robotics. So I'm going to talk in detail about how robotics play a vital role in civil engineering. Okay, and its application and challenges. So when I say automation, first we need to know what is automation. That is construction automation. So construction automation is an application of robotic systems, unmanned aerial vehicles, that is drones, intelligent machineries, sensor networks, and software tools to perform or assist tasks in the design, planning, fabrication, assembly, inspection, and operation phases of the projects. So it is all like put together. We can say whether if you use robotics or if you use drones. So whatever the machinery we are going to use, which makes the task a little more simpler, or it leads to make the task more effective. Okay, that is why we are using automation. So everything will be automated so that we won't have much human interference. Okay, human interference in the building projects. That is, it can be anything. It can be design or planning, fabrication, inspection, operation, any stages of the project. We can say if it is automated means there will be much involvement of manpower. Okay, the manual labor will be significantly reduced. Okay, that is the main purpose of we are moving towards automation. Okay, and the main aim is to reduce the manual labor, and at the same time it improves accuracy. Accuracy means when I use robotics or any machineries. Okay, so machineries, when I use machinery instead of manpower, then the accuracy in performing the task will be higher. Okay, so it will be more accurate, the work or any kind of work. It can be brickwork or plastering or lifting an object and transporting the material. Anything we do with the help of machinery, then the accuracy will be more. Okay, so the increased safety, the safety of the environment, safety of the labor is becomes less risk. Okay, so usually when the manpower is involved, there will be safety issue. So we will be spending much money into the safety aspects, while spending money on PPE or safety shoes. All those things are there, so we can eliminate those things. Okay, when I use automation and accelerate timelines, it means that we can finish the project within the given timeline. Okay, so one of the main important objectives of any construction project is we have to complete the project within the given timeline and given cost. That is our main objective, right? So when I want to complete the task in a given timeline, then when I switch over to automation, then my objective will becomes more easy. Okay, and one more important thing is it enables continuous monitoring and control. Okay, so we can make sure that if there is any error, so we can able to rectify it then and there. Okay, through construction automation. Okay, we can get the real-time data more quickly, and we can do any kind of changes whenever it's required. So why automation? So why do we need automation is like just now I explained the advantages of automation, right? So we need the much problems in the existing scenario is labor shortage. So in current scenario, there is a problem called labor shortage or labor risk. Okay, risk is involved in the project because if the manpower is not there, then we can't schedule the project. We can't perform the project within the given timeline or the given cost. So eventually your cost and time of the project will get higher. Okay, we cannot finish the project within the given timeline if there is any labor shortage. And the second aspect is safety concern. So safety concern means just now I said when I use automation, the safety will be improved, or we can't much give more priority to safety. Okay, safety will be ensured when I use automation, because now the safety becomes more problem in today's construction projects. Why? Because when I used to construct high-rise building, the problem is the people working in a height of like 50 stories or 60 stories, they have a probability of falling from a height. Okay, so one of the major issue in our high-rise building is people falling from height. Okay, that becomes more safety concern in high-rise building. Okay, so that kind of aspect will be improved when I go for automation. And improved productivity, just now I said the labor productivity becomes more important, because if the labor working in a build building projects, if the labor is performing so the slow, so when he performs slow, then eventually the all other tasks will be affected because of this particular task. Okay, so when I monitor the project, if I find there is a slowness in the project, what happens is it directly affects the cost of your project. Okay, that is why productivity becomes more important in today's scenario, because we are our main objective is to make sure our project is getting a profit. Okay, so when I deliver profitable project, only then the client, or the person who invests money will get happy. Okay, and then will move to some other project, or it will benefit the company. So that is why productivity becomes more important here. Okay, so when I use automation, the productivity is altogether it will improve because the equipment we are using is, it's not like manpower or human. Okay, unlike human, it will have a high productivity, and it will work on its own through our input. Okay, so whatever input we are giving, so it will analyze the input and it will work. Okay, so the next aspect of problem is monitoring and quality issue. So the current scenario, we are facing a lot of quality issue and the monitoring problem. So we cannot make sure our engineers are continuously in our site and monitor everything, and we collect data. So it's not possible. Okay, so sometimes we might fall short, and we can forget to monitor some data. So those data will be when I replace with automation, this monitoring uh, will be rectified. Okay, so next aspect is another important thing that is in our current scenario: waste reduction and sustainability. So when I use automation, so the sustainability of the project is gets improved. Okay, it means the lesser waste is, less waste is being produced, unlike the conventional projects where we are not using any automation. So when I move towards that kind of a project, then we can able to see a lot of waste is getting from the project. Okay, so waste means I'm talking about the debris, any concrete waste or brick waste, mortar waste, something like that. Okay, so these waste are coming from projects because of the low productivity, or sometimes overutilization of work, underutilization of the material. So due to all those factors, the waste is being produced in the projects. So these things will be rectified when I adopt automation. Okay, so this is the current trend. It is a much older data, but just look at the trend. If it is a construction company, you can see the trend here. Example, yeah, you can see the trend here. It's in 1990, it was like it was higher, and when time goes, it coming down. Okay, the construction industry, the labor productivity is getting down. When I look over the other industry, like example, manufacturing or any other industry, the productivity is getting increased. Okay, you can see the trend here. Only the construction industry, the labor productivity is getting decreased. The reason is, the main reason is, unlike other industries, construction industry, we are performing a unique task. Okay, the laborers are not performing the same task every day, because manufacturing industry, labor is performing a task which is repetitive in nature. Okay, so he is performing the same task day 1, day 2, day 3, day 4, every day he is performing the same task. So that is the reason why we can see this kind of a trend. Okay, but in construction industry, why this trend is getting decreases, because of we are performing a unique task in our in our construction projects. A labor or mason is performing a task in today, you'll not be performing the same task tomorrow, okay, and day after tomorrow you'll be performing some other task. So due to this reason, why the productivity is getting decrease here, okay. So this is another trend showing material usage. You can see construction materials, this factors. So this orange line shows the construction industry, means that the material usage is getting increased, okay. Lot of materials have been used in our construction as a construction projects, where unlike other projects, you can see agricultural or industrial projects, when compared to that, our construction materials are being used in larger amount, okay. Due to many factors are there, but I'm just saying these are some trend. So why I'm saying these two things are, we need to make sure that our materials and labor productivity should be optimized in a way that it should not be wasted, okay. A material should not be wasted, or a labor man hours should not be wasted. So when I say wasted means it is not being used properly in our construction site. So what is the reason, or what is the solution means, the ultimate solution would be we can move towards automation, okay. So when I say automation, the first thing we need to know, very basic, is Internet of Things. Okay, IoT. So IoT, some of you might have heard about this term, IoT. So IoT is nothing but it is a network of interconnected devices or objects embedded with sensors, software, and other technologies that enable them to collect, exchange, and act on data. So when I say act on data, it means that it can analyze on its own. Okay, it can able to analyze, or it can able to evaluate the data. So whatever data it collects, it will exchange between the medium, and it will analyze. Okay, analyze, and it will give to the output. So that is the main terminology for IoT. So IoT definition just goes beyond just smart gadgets. So when I say IoT, the examples would be like a smartphone, or computers, or wide range of devices that we use in our household appliances, or any medical devices or vehicles. Even today, we are using ADAS in our the cars. Okay, in the cars we are using ADAS, automatic driving system, something like that. So it will automatically detects what objects are there, or what kind of vehicle is moving towards us, and it will automatically stop the. Okay, it will automatically stop the vehicle. So that is one example we can see when I talk about IoT. So IoT, the main advantage is the real-time data is being shared, and it will be communicated to one device to another device. Okay, so these objects will talk to each other. So when I say talk to each other means the whatever the device we incorporate in our system, these devices will talk to each other, and it will make informed decision based on the data they collect. Okay, so whatever data it collect, and it will make sure the data has been analyzed, and it will take some decision based on the input we give. Okay, if I want to take some data, I want to know what is the color of this object. It means that it will collect the data, and it will present to the customer, something like that. Okay, so this is the reason why we are using this IoT. But in civil engineering, IoT is being used in wide range of applications. Okay, even in agricultural, or in a smart transportation system. Okay, so various applications are there, but here I'm going to discuss only a few things, and I'll move on to robotics and drones. Okay. So when I say interconnected device, every part and parcel of the the civil engineering infrastructure has been interconnected in our built environment. For example, you can take building, or take any water project or irrigation project. All the data are clustered in a in a urban area, and whatever the data we want, we can just take it from there. Okay, in a cloud. Okay, that is the main advantages of IoT. So everything will be interconnected. Okay, it will look like a cluster of data, but we can take whatever the data we want from the system. Okay, and the main advantage here is in our civil engineering is it will improve the efficiency of the construction sector till from the production till the the maintenance phase. So when I say phase means starting from design, construction, operation, and maintenance phase. Each and every stage we can incorporate IoT in our projects. Okay. So just an applications. So IoT is applied in different domains of civil engineering, like buildings, dams, roadways, railways, sewage systems, etc. And the main objective is to improve the occupant comfort, operation of building systems, reduction in energy consumption. Example, you can take energy meter will be installed where in automatically it will show that if it increases the threshold limit, it will give some alarm to the user. Okay, we are using so much of unit of energy in our building, or sometimes automatic lighting system. Okay, so automatic lights will be there whenever the human is getting into the building, the light will switch on and it will switch off whenever it is not in use. So these things are some examples of IoT in our day-to-day life. And reduced operating and maintenance cost, increased security. So IoT will increase the security of the system, and it will also improve the life cycle of equipment and related utilities. So any devices, any existing building can be converted into smart building by installing a smart devices or smart sensors. So just I want to highlight here that any building which is not integrated with IoT, okay, in existing projects, it can be converted into smart building or smart intelligent building by installing smart devices. Okay, that we should know. Okay, whatever smart devices, if we install them, then the building will be converted into smart building. Okay, a smart building or intelligent building is a structure which uses automation through IoT to control buildings operations like HVAC, lighting, security, energy optimization, etc. And this can be employed by the use of sensors, actuators, and microchips. So these three important components that have been used to collect the data and processing the data according to the building's functional requirements. So whatever requirements we want, we can employ the certain data. For example, sensors means I can use a temperature sensor. Okay, something temperature sensor to monitor the temperature. Okay, so we can use different sensors based on the requirement. Okay, so smart buildings, so it is applied in the examples of smart infrastructure means educational, transportation facility, smart office building, healthcare facility, hospitals, parking lot. So these are different places where we can apply smart sensors or smart devices. Okay, so let me move on to the main aspect of this lecture, that is drones. So the historical background and equipment, that means how we are using drones in the early stages. Okay, so the past, there was an history, like long history dating back to 1849, where some of the soldiers were using unmanned balloons filled with explosives. So during the Austro-Italian War to attack the Venice, that is mean there is a war that has been going on from Austria versus Italy. Okay, so during the war they used to use this kind of large unmanned balloons. So used to drop the explosive from the night. So that is the first thing where humans have used drones. Okay, in 1849. So, however, large scale use of drones began using the World War One, and again during the timeline, during the time of after some period, we were using only for the purpose of war. Okay, so we are using drones only for the purpose of war and other things. So in 1916, Britain developed the first aircraft drone. Okay, that is called as Ruston Proctor Aerial Target, followed in 1918 by the US Kettering Buck, an experimental aerial system with flying bomb. So these are things that we need to know, because what is the purpose that drones has been come into place. Okay, just you can look at the images here. So you can see these images are still it is there in the museum. Okay, museum in the United States. So you can see in the right side image, this is where the drones have been used, and the bombs have been deployed using the drone. Okay, so it is all like unmanned balloons. So humans will not be there, just an explosive will be there. Used to drop the bombs from the night. Okay, and this is an aircraft where we again use the we will deploy the explosives in the aircraft. Okay, so this is the purpose why drones have been come into place in early stages. So in a modern drone era, began in 1960s, which both in the United States and Russia developing drones primarily for military purpose. So just now I told what are the different purposes that we using drones in the early stages. While military applications have driven drone research for many years, drones have been used in today's various fields. Example, agricultural, environmental monitoring, public safety, security, media, entertainment, etc. And use of drones in civil engineering, especially inspection, is significantly increasing. So this is the part where I'm going to describe in detail. Okay, so there will be a number of application will be there, but in civil engineering, in modern construction projects, drones have been used for predominantly for inspections. Okay, for any inspection, structural inspection or bridge inspections. Okay, and existing problem is the traditional approaches based on the contact sensing have some drawbacks. So usually when I say inspection, what is the traditional way is like the humans will be going to the bridge, whatever the structure we are going to inspect, and we will collect the data and we will analyze, then and there. Okay, it will take more time to analyze and will more time to get the output. So that is the main traditional approach we are doing in the early days. So the problem here is the cost. The cost will be more. Okay, when I don't use any drones, when I use manpower to collect the data, so you will be having lot of manpower will be there, and you will be installing so much of other structures. Okay, to collect all the data. So the cost of intensive instrumentation for the bridge can be very high. Okay, uh, so when I say bridge monitoring, it is nothing but structural health monitoring. Okay, structural health monitoring, to detect any damages are there in the bridges. So those things will be collected using the drones here. So once the contact type SHM is installed on the bridge, the components often not reusable for other structures. So the components are prone to fault, and during the extreme condition, the critical structural health information is needed. So it means that whenever there is a extreme weather condition, it prones to fault. It gives fault data. Okay, wow. So the solution is drones. So using drones, we can able to we can incorporate cameras and other sensors in our drones, and it will collect the data, and it will give the user what is the required data we need. Okay, it will also process in a software, and it will give the data. Okay, so the numerous terms have been used for drones, such as unmanned aerial vehicle, unmanned aircraft system, and remotely piloted aircraft, and remotely piloted vehicle. So these are different terms that we use in our civil engineering domain. Sometimes they may use UAV, unmanned aerial vehicle, or sometimes they use drone. Everything is same. Okay, and these are the different types of drones based on their weight: heavy, medium, light, and micro. So based on the weight, they have classified the drones in different way. So unmanned vehicles means vehicles without onboard operators. So when I say unmanned, means there won't be any man. There won't be any operator to operate. Okay, so it will be operated remotely in some other place. So these vehicles are commonly controlled autonomously using onboard sensors and control systems. Okay. So drone-based inspection offers several advantages. So I'm just going to list a few advantages. Okay, though they provide a versatile and efficient means of data collection and monitoring, and perform detailed inspection and detect superficial image and even assess dynamic parameters. So when I say bridge inspection, so bridge inspection means structural health monitoring. When I say that, then we need to collect all the data from the bridge. Okay, so we need to detect all the damages or dynamic parameters. What kind of vibration is going on? Okay, what is the total moving load is there? So all those data should be gathered in a single platform. So those data will be gathered in the drone, and the drone will process the data and will transfer to some other place in a cloud, where the software will process, and we will get the output. Okay, so large amount of information can be obtained from drone sensors, including high quality images and videos, which can be stored on a memory cards inside the drone and later processed and delivered to the ground station deployed in the area of interest. It means that everything we collect will be then and there transferred to some other place. Okay, so some other place means it can be have some deploy station where the people will be there. They will analyze the data. For whatever data we need, we can get it from the deploy station. And the main aspect is high quality images and videos. So these are the things that we're going to collect. Okay, in drones, just we are collecting only the images and videos. We are going to capture those things, and after capturing, we are going to analyze it. Okay, so this is a specification of self-build drones. You can look over and can just take a glance of this different drone model and its application. For example, you can take DJM DJI and M200. Okay, so you can see cable force estimation, Mavic Eye Air for vibration measurement. So these are different types. That if it is a commercial or self-built. Self-built means we can assemble it on our own. Okay, so these are different drones that you can use. And sensor means you can see 720 pixel resolution with 30 FPS sensors have been used, and sometimes 4K resolution have been used for some. For some model, we have a DSLR camera with 1D lidar systems. So these are different specifications that we can look over when we adopt drone in our civil engineering. Okay, payload means how much weight it can carry. Okay, and the flight time, how much time it will take. For example, some drones will take 12 minutes. Okay, some drones will take 27 minutes, longer duration or shorter duration. Okay, it depends on drone to drone. Okay, why I'm showing this are, we cannot say every drone will have same capabilities or same specifications. The specification of the drone will differ from drone to drone. So we have different models here. That is why I'm showing this. Okay, so these are the different components of drone. Representative drone equipped with different components. I'm just showing this drone as a representative because some components may not be there for some other drone. Okay, it will differ from drone to drone, but these are some basic components we can identify. One is propeller. Propeller is so important. You can see here propeller. So there will be a wing. Okay, on four direction. Okay, so there is a camera in the bottom, and we have a lithium polymer battery, and we have gimbal. Gimbal is to make sure our drone is stable. Okay, so we need to make sure our drone has stable plane. Stability should be important. Okay, so that is why we are using 3-axis gimbal here. And we have a navigation system, that is, it comprises of GPS module, inertial measurement unit, and flight controller. And we have another part, ground control system. So where the person is going to control in a remote control, you're going to handle, you're going to make sure the drone is going to the particular designated location. So those things come under ground control system. Okay, the different components of drone, just I'll quickly explain this. That is airframe. Airframe means the body. Okay, it is constructed from a rigid plastic which must absorb and dissipate vibration from the propeller, and motors, while being durable enough to withstand the impact. So airframe means nothing but the white frame that we use in a body. Okay, so that should be very rigid to absorb and dissipate any vibration. So when I use drones, for example, if your drone is flying under height of around 50 or 60 meters, there will be a wind effect on the drone. So due to wind effect, the drone might vibrate, or drone might move from one place to another place. So it should resist that. Okay, that is why we are using airframe, which is made up of rigid plastic or rigid, the carbon material. So propulsion system, it is consist of motors and propellers with four or more motors providing the necessary thrust to lift and maneuver by varying their leaf speeds insignificantly, and propellers to that generate lift and thrust significantly, influencing flight performance and efficiency. So the propulsion system, which I told you, propulsion, okay, you can see here. So these things, these four propellers plays a vital role in lifting the drone. Okay, it will provide necessary thrust for lifting the drone, and it will make sure that the speed has been adjusted. It generates, certain thrust, which will affect the flight performance and flight efficiency. Okay, so why I'm saying all those things are, like, we cannot simply fly the drone and we can get the data. There are a lot of factors that we need to see. That is why I'm telling all this. And communication system is like exchange of communication between the drone and the ground station. Okay, that is one component we have. And navigation system, the flight control unit, which processes sensor data, and we are using GNSS, that is ground navigation satellite system, for locating the data, enabling autonomous flight path and position hold. It means that we need to check whether there is any obstacle in the environment. Okay, why we need to check? Because if there is any obstacle, we cannot simply fly the drone in some certain region. If there is any obstacle, we need to see whether the obstacle will endanger the drone, or we need to see whether there is a possibility of changing the flight path. Okay, And the power system means the battery. Okay, the flight, the drone has to getting the power from the battery, right? So battery, power distribution board, and electronic speed controllers, that comes under the power system. So it runs in a battery. Okay, that is the main aspect we need to know. Additionally, various sensors have been used: barometers, optical flow sensors, ultrasonic sensors. So these sensors will collect the data. We need to take some data, right? So through this sensors, we are going to collect and we're going to transfer the data, right? And some of the key devices we need to use in our drone here is RGB image camera devices. It means that it is very much essential for the drones to capture the real digital images or videos, because it will capture the images through some resolution. Okay, there are some advanced models such as RGB sensors, which will enhance the capability by recording pixel depth and other information, which will support the 3D reconstruction of the infrastructure. See, the main purpose why we are using this kind of RGB camera device means we will capture the images. Okay, the image will be captured and it will reconstruct that image in a 3D form. Okay, that is why we are capturing this kind of devices through some devices. So we have another device, LiDAR, that is light ranging and light detection and ranging sensors. So it will use laser pulse to measure the distance from single points with exceptional speed, often scanning thousands to millions of points per second. So it will scan, thousands to million points per second. Okay, so this rapid data collection allows the creation of detailed 3D point clouds. Okay, so when I say bridge monitoring, the main purpose of doing this bridge monitoring is to find out whether there is any cracks or delamination, or whether there is any structural fault in our bridge structures. So we if we want to find out, then we can use this kind of LiDAR sensor. So LiDAR sensor will collect so much of information, and it will create a 3D point clouds where it will reveal the surface level cracks or delamination in our bridge. Okay, thermal sensor, it to detect any temperature surface variation. Okay, if there is any water leakage, when you want to find the water leakage or insulation problems, we can use for this kind of thermal sensor. And you can see these different sensors that we incorporate in our drones. Okay, camera, LiDAR sensor, and infrastructure sensor. So NIR means near infrared sensor. It is costly and less commonly used. It is a combination of both infrared and RGB sensor. Okay, so most probably when I want to find out whether there is any surface damage like moisture infiltration or surface level concrete spalling, so if you want to find out those things, then we can use NIR sensor. So we can do many specialized inspection if you want to do it in our bridge structures. So these are some important points that we need to know while incorporating drones in our modern construction projects. For example, weight of the drone. Weight means self weight of the drone. Okay, it plays a vital role which impacts the flight autonomy, because heavier drones can fly for less time. So you can just see, if the weight of the drone is increased, then there will be lesser time for the drone to capture the image. Okay, so simultaneously we can say lighter drone can extend the flight times. So if the drone is lighter, then we can we can use drone for longer duration. Okay, so the reason is it will reduce the risk of overheating issues also. But what is the problem here is heavier drones can perform better in wind conditions. If there is any heavy wind is there in our height of more than 50 meter or 100 meters, then effect of wind will be there. So under heavy wind or heavy air pressure or something like that, the heavier drones will be giving better performance than the lighter drone. Okay, when I say lighter drone means the weight I'm talking. Okay, so lighter drones have some issues here. Okay, due to wind effect, it cannot capture, it cannot give better performance. Okay, so the drones has to withstand at least a wind speed of 10 meter per second to minimize the vibration and sudden movement caused by the air turbulence. So there will be a turbulence will be there, vibration will be there. It need to at least have certain capability to withstand it. Okay, that is what I'm saying, 10 meter per second. Okay. So zoom capabilities, the drones that we capture image, we cannot just directly go into the bridge structures, with a less distance of 500 mm. Okay, we will have some certain distance from bridge to our drone, so it will capture the data through zoom capabilities only. Okay, so zoom becomes more important, allowing the close-up inspection of structural features and enabling the detection of small defects from a distance. Okay, so high resolution plays an important role because high quality camera is required, right? So to capture all the images, so even a small displacement is there, we need to make sure that it's captured in our camera. Okay, so we also need another aspect called gimbal. So I just now explained this. Gimbal means for stabilizing the camera. So gimbal plays a vital role in stabilizing the camera. That means that whenever there is any vibration or due to effect of wind, it will stabilize the camera. It will make sure that the camera captures an images properly. Okay. So gimbal not only isolate the camera from the drone's vibration, but also vital for capturing smooth, clear videos, right? So I'm going to explain about the bridge monitoring. I mean, drone-based bridge monitoring. So these are simple steps that we come across when I go for bridge monitoring. Okay, using drones. So first we need to collect the data. That is through drones. We're going to collect the data, and we are going to transmit the data and process it, and we are going to make decision making. All right. So these are some different applications of aerial inspection. You can see here, it is not only applied for bridge inspection, it can also be applied for buildings, roads, wind turbine, or for photovoltaic power system inspection, or transmission line inspection, or pipeline inspection. So there are, different applications are there. But in this lecture, I'm going to concentrate more on bridge inspection. Okay, how bridge inspection can be carried out. Okay, the case study is inspection of bridges. So the main objective of doing this inspection is to find the whether there is any structural fault or any issue in our bridge structures. Issue in any cracks or surface level damages are there. So we need to find out the critical issue of the bridge. Okay, current status of the bridge with respect to the service. Okay, for example, a visual inspection of bridge structure is to monitor the bridge status and ensuring the ongoing serviceability of the structure. So whether it is functioning properly or not. If not, then what is the problem behind it? And those things we need to find out using the drone. Okay, so unmanned aerial vehicle can be used for ensuring bridge inspection safety. Okay, we are going to use drone here. The drone will go into the place, go into the bridge inspection place where it needs to be inspected, and it will collect all the data, it will collect all the images, videos, and it will send the data to some deployed station, and from there we will analyze and we will get the data, right? And this is for inspection safety. What are the different criteria? We go for different stages like pre-inspection, inspection, and post-inspection. So in pre-inspection, you can just see before inspection what are the things that we do. For example, you will be identifying some access point, identifying areas like cracks, bridge components, identifying hazardous area. Sorry. So the main inspection phase, which involves the on-site inspection using drones. In case of surface damage detection, it is advisable to initially capture the overview of entire bridge, and then we can go for detailed information on each structural and non-structural component. So basically, we're going to capture all the necessary information which are related to our bridge inspection, bridge structure. Okay, so the drones are need to be remain stable, which maintain its position throughout the entire survey. Okay, so and due to wind or weather condition will be differ from place to place, so it adversely affect the impact of drone performance. So at the end of this phase, all the collected inspection data is stored and go for post processing. Basically, in the inspection phase, we are going to collect the data. Okay, we are going to remain stable in a particular point, and it will collect the data. Okay, it will capture images and it will store it. Okay, and it will similarly it will do for every other point. Okay, in our bridge structure, and every point it will capture image and it will send the data to the cloud or deploy station, and it moves to the post processing stages. The post inspection, where we collect that is the high quality images, right? So the high quality 3D model of the structure through photogrammetry. The acquired images are processed for visualization, damage assessment, and model analysis. And we are going to find the damage detection using some softwares. Commercial software is there, that is Photoscan, Pix 4D Mapper, as well as the open source projects like CoalMap or WebODM. Okay, these softwares are used for 3D structure reconstruction. So whatever image we capture, we can put as an input for this software, and the software will analyze, and we can able to produce, like, create a 3D structure reconstruction, like whether there is any defect or whether there is any delamination or surface level fault. So those things will be mapped in a software. Okay, so eventually, when damage is identified on the bridge, an in-depth condition assessment of the structural member is conducted. Okay. So path planning and optimization, this is very important, because there are few criteria while we need to consider while doing our flight operations. Okay, so flight operation means drone. Okay, I'm talking about flight duration of drones. So the first thing is identify the point of interest. Point of interest means the point at which it's going to capture the data. So that we need to identify, and we need to plan an efficient traversal route for the drone to minimize overall flight time while maximizing the battery life. So it has to make sure that it is spending lesser time and capturing more images. We need to plan in a such a way that it maximizes the battery life, but also minimizes the overall flight duration. Okay, so when planning the flight path of the drone, several criteria has been addressed. I'm just listing few things. That is, ensuring collision-free flight, meaning that it should not collide with some objects. It should not interfere with some other obstacle, and it should achieve full coverage of structure, obtaining images of sufficient quality, feature detection. Identifying the detection, minimizing the number of images, devising efficient flight route. So these are some things that we need to address while planning for flight path. Okay. So when I say flight path, the one method that we are going to adopt here is the STIP method. STIP method means horizontal steps we are going to create, we are going to capture using our flight path. Example, you can see here this image. So you can see here there is a point, right? For example, in a pier or a bridge, so you can see here there is a lot of lines have been drawn. It means that each and every line has been drawn to a point. That point is called point of interest. So it means that the drone will capture each and every point that has been located here. So it has been planned in such a way that drones has been capturing image in a circular form. Okay, so this method is called STIP method. Okay, these horizontal steps are more effective, particularly when combined with low flight speed. So here in this method, we are deploying the flight in a lower speed. Okay, so it will capture the data at a lower flight speed. When I say lower flight speed, mean it captures data with high accuracy, right? So another important factor is optimal distance between drone and the target. So we need to make sure there is a optimal distance has been maintained between the drone and the target. So usually it will be around 1 meter or 1.5 meter based on the situation, right? So the distance become more effective. Just now I said under poor lighting condition, we can say 0.3 meter is required. Under a good lighting condition, 1.1 meter is very much required here. And speed becomes important because speed will affect the balance of the drone. Okay, so if it is flying fast, then it won't capture high quality image. Okay, only when you fly slow or lesser speed, it will capture high quality image, right? So, so this timing of the flight becomes another crucial factor because shadow or daylight or solar radiation, these things will cause overexposure during the image acquisition, and it will affect the output of the data that we collect. So, for example, you can say in night time, if you collect the data, it will collect the data in lesser resolution, and it won't give much more detail in our images. So there is a standard time to collect the data. For example, in an evening when you collect the data, there will be lesser interference for solar radiation and shadow occlusion. Okay, so another main issue in our drone inspection is low battery. So we all know it has been operated under some power or external battery source. So drone will be unable to complete the entire mission or scheduled flight path if there is any battery issue. Okay, this could lead to have unexpected damage or insufficient charging before mission commencement. So we need to have overcome this issue. So we need to have specific threshold in our drone where the battery level is continuously monitored during the mission. Whenever it reaches the drone, then we can make sure the drone initiates return to its home point, that is the deploy station. So we need to monitor continuously the battery voltage and how much battery capacity it has. Okay. So we have another aspect here, that is Internet of Drones. It means that we are going to have different different drones put together, interconnected, and it will communicate each with one another, and it will act as a single network. Okay, so this is called Internet of Drones. When network of drones are involved in rich network monitoring, that is a purpose why we are using Internet of Drones. It is quite advanced, but I'm just saying because it is more connected to this drone in based inspection. So you can see the image. We have a drone swarm here. Swarm means more than one drones. Okay, will be having different hundreds of drones will be there. Where drones will collect the data and we will send it to the satellite, and from there we will deploy station will get the data from the satellite, and we will send the data to the cloud, and from there we will analyze it and we will give it to the customer or the people. So this is the IoT architecture. So the critical issue is flight duration, inter-drone conflict. That means that drone to drone, there will be some conflict if I use this kind of Internet of Drones, right? So flight duration becomes important, critical issue, and communication channel because whatever we say, that is the drone-based inspection or Internet of Drones, the first thing that we need is we need to whatever data we collect, we need to transfer it, right? So we need to communicate that data to some other channel. So we need to have wireless medium. Okay, so main important challenge in drone based inspection is communication. That is, we need to have proper network. Okay, so due to network issue, we cannot, if it is not transferring the data, then it becomes more difficult to analyze the data or get the output. So wireless medium is much more important because in nowadays in our rural area we are using still the wired medium. Okay, wired networks are being used. So the mobility will be low mobility will be there. So security issues will be there. So easily it can be hacked by some other person if at all they can access the data. So that is one issue that we can have for this part. So how it can be employed in urban scenario, because it can be used for real-time monitoring like air quality, noise and rubbish detection. Also, it can be adopted for traffic improvement. If there is any congestion of traffic, detection of accidents, road conditions, etc. So using this kind of Internet of Drones, we can able to identify those things. Okay, it can be deployed in this urban settings. So challenges, just now I talked vibration. Vibration becomes more important issue. Vibration caused by external source, vibration caused by maneuvers or aerodynamic source like AB wind, stabilization system, or by engine itself. So by drones will have propellers, right? So propellers will rotate at some speed. So due to this propeller, the vibration uh, will be coming from the propeller itself. So due to this vibration, the flight performance will be affected, right? So these things that we need to check before we are going for drone-based inspection. That is inspection time frame, when and where we are going to go for drone-based inspection. For example, we are going for shadow, daylight, or solar radiation. During which time we are going? For example, if it is sunset or sunrise. For example, if it is sunset or sunrise, the solar radiation will have some negative impact on the images, and it will give false positive output. Okay, so we need to avoid those things because it will have direct reflection of the sun. So from that reflection, if you collect the data, analyze it, and then we get false data, or sometimes it will lead to poor data. Okay, so the distance between drone and in specimen also is important. So usually we need to have 1 meter distance from the surface to ensure we have proper visibility for the detection of small scale cracks in concrete structures. So reflection, just now I talked, like if you are doing the drone-based inspection, the one thing that we need to see is when we are going to do inspection. So whether we have the effect of reflection on our surface, okay, the surrounding objects. So due to the surrounding objects reflection, the drone will collect the data which is having some sort of abnormalities. Okay, abnormalities means there will be some false data will be there. Okay, so it is a very standard practice that we do whenever we are recording doing the drone-based inspection. So physical access means whether there is any obstacle in the surroundings that we need to check. Okay, whether if at all we are going for drone-based inspection. So after getting all the images from the drone, we are going to stitch all the images like this. So this is an example of stitching, image stitching. So this is an aerial thermographic image stitching where we collect all the captured image and we will stitch together and we will create a 3D reconstruction images. Okay, so this is like an example I'm just showing. Okay, it will detect the features and it will match the features and it will apply the transformation based on homographic matrix and it will create a larger image. So this is another example, real-time image of how bridge-based inspection, drone-based inspection taking place in bridge. You can see here that is the drone has been inspected and it shows that there is an efflorescence, there is a spalling of concrete in the bottom of the pier deck. Okay, spalling has been found out and there is a rebar. Okay, it is all these things are identified using the drone. Okay, whatever the images that we captured using drone. So this is a purpose or purpose why we are using drones in bridge monitoring. This is one application. Okay, so we have different application which I discussed in the earlier part. Okay, the next part is robotics. So the one part of the lecture is this drone and another part is robotics. So robotics, why we need robotics? The main aspect is like high labor cost, high risk involved in labor usage, high cutting corners, like low production efficiency. So when I use manual labor, we have many issues like labor cost, low production efficiency, and high risk involved in using the labor in our projects. So safety concerns are there. So we need to avoid those things. That is the reason why we are moving towards construction robotics. Okay. So I'm just saying what is the different way that we can adopt a robot in our build environment or building projects. So this is an example of how robot-oriented design. That means that robot has been employed in our industrial sector. Like example, when I'm going to lift an heavy objects, okay, lift and transport an object, we can use this kind of robotic arms. Okay, so robotic arms for lifting and handling all the equipments. Okay, kind of when I use manually, it means that we can use crane or any other without machine we can use other equipment to lift and handle. But here they are using robot oriented design where we can give the instruction and robot itself will handle everything. Okay, And robot-oriented industrialization means much more effective large-scale prefabrication, meaning that you take an example here. So you can see here, old building component has been constructed in our industry. Okay, so everything will be done by the robot itself. So whether all the building component, not a single brick, I'm talking about the full wall. Okay, so all the walls, doors, windows, everything will be fixed, and the whole building unit has been assembled in our closed environment. Okay, industry. So it is being done by the robot. So that is what I'm saying, robotic industrialization. Okay, where it is being customized to our user requirement, or where we can say that it's prefabricated, but using the robotics. Okay, so we are using large scale prefabrication using robotic systems. So it is highly mechanized. Okay, it is highly mechanized, automated, and robot supported industrial settings. Okay, so next part where we can use robots are construction robots, elementary technologies, and single task construction robots, where we are going to use certain robots for to execute specific construction task in a repetitive manner. For example, if we need to paint it, we need to paint the building, then we can use a robot that is very specialized for painting. Suppose I'm going to do brickwork, then we can go for a robot that can do brickwork. So for a specific task, repetitive task, then we can adopt such kind of methods. Okay, and these are some examples that we can see. That is a robotic system for intra-house mobility and logistics. So these are some things that we can come across in our daily day-to-day life. Like for example, you can see it heavy-duty logistics robots, floor cleaning robots, robot platform, and telepresence robot. Some of the examples that we can see it in our airport. Okay, window cleaning robot is also there. Okay, for in high-rise building where we can deploy this kind of robot. And these are different thematic field into which automation and robotics is currently advances. So these are different area where it's been used, and it's been under research. Okay, for example, you can say automated robotic environment. So different areas there, like example, intelligent energy distribution, home and office automation, housing production, automated mining. So automation has been incorporated in different sectors. Okay, so in this robotics, I'm going to explain more about a particular robot called mobile construction robot. Okay, so before that, I'm going to explain what is mobile manipulators. Mobile manipulators means it is a mechanical arm mounted on a skeleton of the mobile robots. Okay, it is a mechanical arm, just an arm which is mounted on a skeleton of mobile robots, which enables the end effector to achieve desired motions through coordinated movements of both skeletal and mechanical arm. So if you can't understand this, then I will show this image. Okay, you can see here mobile construction robots. You can see in the top, you can say manipulator. So this robotic arm that in the end we can say it is a manipulator. This component is called manipulator, and this part is called end effector. Okay, this part is called end effector. So the mobile platform is that we see here is we will be consist of both tracked, wheeled, or something like this. Okay, mechanism wheel platform. So different platform will be there, and we have different robots like collaborative robot, industrial robot, and low degree of freedom robot. Low degree of freedom means it will have lesser you have restriction on the movements. Okay, lesser degree of freedom. So it won't have 360-degree movement. Okay, it will have certain constraints in our movement. Okay, so these are some components of mobile construction robot, like mobile platform, sensors, and user interface, and the control center unit will be there. And classification of robots by process task. So we have a building where the full life cycle of the building, we can deploy robots starting from the construction. In construction, we can use prefabrication production robot or on-site robots. In the demolition also, we can use demolition demolition robots, where the robots will start demolishing the building components. Okay. In operation and maintenance, we can also have maintenance robot, cleaning robots. Okay. So we cannot say robots have been used only for the construction activity during the operation. Okay, but also it's been used for demolition, construction, operation, maintenance. In every phase of the project, it's been used, right? So this is another example where mobile construction robots have been used for brickwork. Okay, brickwork, just an example of how brickwork has been done, okay, using this mobile manipulators. So you can see here in the images where there is no human involved in this part. Just a robot has been configured in such a way it will lift the brick and it will lay it in some place. So that is the main purpose of incorporating this robot in our built environment. So these are some commercially available MCR, and this is another example of another MCR, that is mobile construction robot. The main problem here is there is a one issue, that is environmental complexity, which will make MCR more difficult to navigate and control. So navigation becomes more difficult if I have environmental complexity, like there is any hindrance around the robots. It is very difficult to adopt or detect any hindrances there or not. Okay, so it will have, if you have any hindrance, then it will we cannot navigate it properly in our projects. So these are some different applications like where MCR have been used, like 3D printing, spray decoration, demolition, sealing, plotting, baseline, etc. And these are some factors that we need to see while designing a mobile construction robots. For example, mapping and navigation, localization, planning and control, etc. And I'll just explain this in detail. Okay. So most of the case, the MCR application still in the laboratory stage, but in the future, we can say that it can incorporate in any prefabrication production or in any construction projects, right? So this is another example where ideally in a digital construction scenario where robots are deployed in our site. Okay, I'm just going to explain how robots are used in our site. So you can see here there is a robot in the brick, near the brick part. There is a green color, and this is where another robot is there to do the prefabrication process. So this robot is for prefabrication, and this robot is for on-site assembly. So we have only 3 labors here to check and to monitor it. Okay, so the first part is to this basic batch prefabrication will be done and controlled by the person standing here. So he will make sure that prefabrication process take place properly. Once it is done, the factory prefabricated components are moving automatically using the tray, where the tray, I mean, this component is also a robot. Okay, this part is also a robot where the transfer is happening automatically, and it will move to some designated location. Okay, so it will move to this place where this robot will take objects or bricks from this place, and it will place it on the place where you need to put the brickwork. Okay, so this is how we can say the robots can be interacted in our building projects. Okay, so you can see here, we can simply say robots in future will completely eliminate the manpower if at all we install or we can deploy it properly in our site. Okay, another challenge in this ideal scenario is we need to have proper housekeeping. Like example, we need to have proper there should not be any hindrance. Okay, if at all there is any hindrance, then this robots cannot function effectively, right? So technical requirements means how what are the requirements that we need to have for MCR. That is, one is autonomous mobility. So it needs to move from one place to another place without relying on fixed installation. And another aspect is like dexterous manipulation. So you need to manipulate the data, whatever the data it collects from the robot. So see, robots will have sensors installed in a robot. So the sensor will collect the data. Okay, but the purpose is robot will move from one place to another place because having high flexibility and mobility. So safety and interaction becomes another important factor, because in this environment, the human is interfering with the robots. So you can see human machine collaboration. So the machine is not not working by itself. The human will be there to give some instructions, right? So that is why safety becomes more important. So just now I told that there are some factors while designing the MCR, that is control, planning, positioning, perception, safety, and interaction. So while integrating the MCR in built environment, we need to place greater stress on positioning, interaction, and safety. So just look at the image. You can say these are different modules of MCR systems and duties carried by them. You can say awareness, localization, control, and planning. So localization means whether need to identify the object, how it's going to identify. Awareness means how it's going to map the obstacles. So whether the robot is mapping all the entrance around the robot. Okay. So manipulator control means this part, that is control means motion control, how it's going to navigate in a project. Path planning means how it's going to plan the trajectory, for example, how it's going to move from one point to another point. So modeling, so just now I told motion planning becomes more important because in case of construction site, so sound planning requires very much important because in a construction site, so every day we cannot say the same process will be carried out, same activity will be carried out. We will have sometimes beam construction, beam concreting. The next day we will have concrete. Some other plastering work will be there, so that we will have a dynamic nature of site. So the site will be changing from day to day. So the motion planning becomes more essential, okay, because it has to work in a complex scenario. Okay. So environmental perception means how it's going to collect all the environmental data, like how it's going to collect surrounding data like awareness, sensors, like lidar, camera, sonar, or GPS system to collect all the data. So it will collect the data, it will map and create own, it will construct its own map of the unknown environment. That process is called SLAM, that is simultaneous localization and mapping. Okay. So you can see here how this mobile construction robot has been used, how it has been taking an object and lifting and carried out using this kind of systems. So the main aspect is it has not only the camera but also lidar and also GPS system to locate the latitude, longitude, and position. Okay, and odometer, speed, to control the speed of the robot. So all those things will be there incorporated in our robot. Only then we can effectively function. Okay. So robot applications in our construction projects, it depends from, different applications are there. I'll just quickly explain this. The single task construction robots, single task means example, bricklaying robots. So for example, I'm going to lay the bricks repetitively in my project. So I can incorporate bricklaying robots, okay, in place of, deploying manpower. So it will directly enhance the safety of the workers also. So multitask construction robot means it will perform different tasks. Okay, from laser leveling to through and brick laying to cutting, painting, plastering, reinforcement, handling, and material handling. So a different task will be handled using this multitask construction robot. So mobile or swarm robots means category. I mean, this category means a set of different drones or robots are being connected, interconnected, and it will act together. Okay, that is called swarm drones. So example, you can see swarm drones means 4 robots act together. Okay, 4 or 5 robots act together to perform a single task. So that is called swarm robots. Okay. Humanoid robot. Humanoid means where it will resemble the human body in terms of appearance, motion, and motion capabilities. In addition, they normally designed with high degree of freedom, making them more flexible when executing tasks. For example, they have developed a robot in Japan, developed a semi-autonomous construction robot, that is HRP-5P, which will replace the human labor in construction roles by performing tasks involving heavy loads. So I'm just showing a video, just you can see here. Yeah, so you can check out. I'm just forwarding. So you can see here the robot has been handling all the big heavy and heavy objects. So they are created an environment. They are checking whether humans are able to lift and carry and do the job. So when compared to humans, the robots have been lifting and handling the heavy materials effectively. So you can see here the robots. So robots are being using to lift the objects without any human interference. robots are being used. So it creates a own environment. Just now I told you, right? A slam. Okay. So it creates a own stuck. It create an environment where it will create a map of the construction site. Okay. I'll just move on to next part. Wearable robot. So wearable robot is nothing but devices that we attach to the humans to increase the physical strength or endurance. Okay. So how it has been used in a equipment tracking on construction machinery or tools? There are some applications that I'll quickly go through. So for example, excavation. So if it is an excavation part, we can use robots in excavation activity. For example, there is no human to excavate it. We will incorporate certain software and we will incorporate all the data, like example, lidar or camera or GPS. So it will fully understand the surroundings and it will navigate in its own, and it will make sure there is no obstacles. So it will provide a real-time 3D maps, and based on the map that it creates, it will work. Okay. Just we need to give some instruction. Based on the instruction, it will work on its own. Okay. So we need to have constant human monitoring. Okay. That is one part we need to have. So this is one example. So this means that we can complete the project at faster rate, and we can complete with the enhanced safety. Okay. Safety of the humans will be there. Okay. So concrete placement, we also use robots for concrete placement. So it will, when I use robots for concrete placement, it reduces concrete material wastage and lowering the cost, and it contributes more eco-friendly construction process. So these are some examples of concrete robots that have been used in our, different countries like US and China. China has been using intelligent follower concrete distribution robot. Okay, I'll just quickly go through this, and you can see in the last column that is number of workers have been used. So they are using only 2 labors instead of 5 labors for a work. So this means that they are completely eliminating the manpower. Okay, they are partially reducing the manpower. At the same time, they are increasing the effectiveness of the operation. Okay. So this is one example of concrete placement. Welding means we can also use for welding, robotic welding, that is for precise and effective, efficient welding capabilities. I'll just move on. So these are different tasks that we can go for intelligent welding system, for handling the system, welding robot, welding equipment. So when we go for welding, then we have to make sure our objectives have been satisfied. Okay. And swarm robotic means many robots working together to complete a single particular task. Okay, that is called swarm robotics. And we can say swarm robots. These are some examples of different robots used in the construction site. Floor leveling robots, blocking robots means screw blocking. That is that we usually do in our construction activity. And basement floor smoothing robot and structural ceiling robot. Okay, so different robots. I'm just showing that mortar placement, tile robot, paint roller coating robot, and brick carrying robot. Okay, so these are all used in China. Okay, but not in India. But still, we are in development stage. I'm just showing some video here. You can see. So you can see here different robots have been used in our building projects. So different task has been carried out by robot itself. So this is another example. Okay. So due to time constraint, I'm just moving quickly. Okay. So 3D printing is also one area where robotics have been deployed. Even in India, we have larger applications have been used effectively in our today's scenario. So 3D printing. So you people have know about 3D printing. Just I'm moving towards another part, that is pile driving. So even robots have been used in semi-autonomous piling machine introduced to make sure that our pile driving is been integrated with GPS. Okay, so use GPS enabled pile driving, we can able to drive the pile with greater accuracy. Okay, we just can't say it is being used for other building projects alone. Even in geotechnical engineering, it is being used. Okay, So vibrations are continuously monitored using this kind of pile driving robots. Okay, and it will consequently reduce the cost and enhance the safety of the workers. Right. Another example is structural assembly. So where the robots will assemble every structural component in our building project. So I'm just showing another video just quickly. So you can see here. So robots have been deployed for structural assembly. So you can see. So yeah, just a finishing work is being carried out by humans. Okay, other than that, everything will be taken care by robots. So this is done in US. Okay, United States. They have Mule 135, which is used to the purpose is to lift and assist the laborers. Okay, the robotic arm which used to carry the materials and lifted and in a place, a designated place. Okay. So this is another example of robots used in rail gantry system for rebars. Okay, for rebar cutting or tying welding operations, we can use this kind of robots. And for additive manufacturing, robots have been used. For example, 3D printing. Okay, example also 3D printing. So this is another example. Just now I told for rebar cutting. So you can see robots have been used for rebar cutting and tying. So another example. So this is another example how robots can do for setting the marking the buildings. Okay, just a robot will do marking. A robot will do all the marking part. It has been controlled remotely by labor or engineer. I hope it's clear. So every plan itself marked by the robot itself. Okay. After marking, the excavator will come and will start doing it. Yeah, the main challenges here is safety challenges. We cannot say the safety might improve, but additionally, the skill and knowledge should be there to operate the robot. Okay, if the skill and knowledge is not there, then it will lead to accident. Okay, because there will be human as well as the robotic interaction will be there. So we need to incorporate proper training for the the laborers working in a built environment to prevent any potential safety hazard or safety issues. So these are some standards that we can incorporate, okay, for human robot collaborations. So adaptability and flexibility challenge. So the robots has to make sure that it adapts to the challenging condition, dynamic nature of the project. So the projects, we will perform different projects in projects, building projects. So different activities will have different challenges. So these challenges, the robotics has to be flexible enough to adopt those challenges. Okay, it has to have proper perception, decision making algorithms, or versatility. Okay, to perform different tasks. So scalability challenge means it has to handle various workload and tasks. Okay, because it can't say that it can only lift a certain capacity. So it has to make sure it has some limit or threshold limit. So it has to do all variety of jobs in our projects. Okay, only then we can deploy it for the large scale projects. Okay, otherwise we cannot deploy it for the small scale, and we can say that it comes. I mean, we can have profit. So scenario is like we have a scenario. I'm just saying an example where robots have been used here. Whenever robots have been used in our building projects, it results that robots for a particular task, if the robot has been used, then we can say the certain manpower has been reduced, okay, in a physical environment. So whenever robot has been used, we can say that we know for transporting or moving or any kind of work, okay, it can be any kind of work, the manpower, the labor that we use in our project, he or she might have lesser productivity, or sometimes due to some external factors, the workers spend less time for transporting or takes more time to handle all those things. So when you replace that with labors, then robots, then we will have better productivity and better performance. Okay. uh, so you can see here robot performing different tasks, from like summoning, accompanying, and sending. So it is all monitored by the human. Okay, that is one part, but all different operations are being carried out by the robot itself. So that is one part I'm going to discuss. That is, whenever we use robots, there is an algorithm called RL, that is reinforced learning. So it is nothing but a ML method, that is machine learning method, which is suitable for systems operating in dynamic environment. So whenever we incorporate RL algorithm, it means that the robot gradually refine a decision-making strategy or a policy in real time by learning from their own interaction with an environment. So it creates their own environment, own interaction. Okay, so it creates, like, for example, I put the robot in a certain project and I'll monitor that. I can see, or I can say that the robot will learn its own way and it will develop its own algorithm. For example, if a robot is finding some difficulty in in a movement, okay, for example, it finds difficult, if you find a solution and it will put the input as some solution to the robot, then in other day we can say that the robot will overcome those issues, okay, because it's learning. Okay, so it is called reinforced learning algorithm. So example, you can see here, they have created a simulation, like they have put the robot in a place where there is any obstacles in the project. So they have monitored it, whether the robot is learning, okay, learning in its own way. So yes, it's proven that the robots are sensing all the objects and it's creating its own path. And after some duration, if the same obstacle is coming across the robot will automatically detect it and it will create another path. Okay, it creates its own path and it will create its own environment. Okay, so initial navigation demonstration with the eye, slim, and movable obstacles. They have created a simulation with different capabilities. Okay, so after the simulation, they have find out that a robot performing and it's creating its own map. So this type of simulation is called sandbox environment. Yeah. So last, just close it up, like economic comparison. So some of you might think, like, if I use robot, then what is the cost? Okay, because the robot will be initial cost will be higher. So eventually I'll be spending more money in my project. So what is the purpose why I'm using this robot, right? So just I'm showing some comparison why we need to adopt robot. Okay, for example, I'm taking an area of around 1,000 meter square area with a height of 2.6 meter, right, building model, and just comparison with robotic with manual labor. Okay, for different works, you can say, for example, I'm taking a painting. Okay, for painting, I can say labor breakdown. Robotics doing some meter square of area. For example, setting inside, transfer between floors, positioning at workstation. So it takes some labor, right? Labor duration or productivity it will take. So I'm just summing up. Okay, optimum. I'm taking some optimum values, and they are checking with manual labor itself. So manual labor takes 8 minutes per meter square, and the total labor required is skilled labor 1.27 for robotic, and here it is required 8 minutes per meter square. So, from this comparison, we can find that excluding material and excluding higher labor rate and lower labor rate, they are comparing with both rates. Okay, higher labor rate and lower labor rate, 3.3 and 1.6. If I compare it, and we can come to a conclusion, that a manual labor, we have savings in the manual labor, which is very significant, because it vary between 60 to 80% in all all tasks, starting from painting, plastering, or brickwork. Okay, so if it is a repetitive work, okay, if I having a building, high-rise building, I'm going to construct. if having a repetitive works like plastering, painting, or brickwork, then we can say that these tasks can be automated. Okay, this task can be automated using the robots, because it significantly reduces your the project cost. Okay, because when I use manpower, the manpower takes some times, wastage will be there, material cost, material wastage will be there, so that you will have a lot of loss will be there. Okay, material wastage or low productivity, safety issues will be there. So we can completely eliminate those aspects, and at the same time we can have some savings in our project. Okay, so that is why I'm saying automation becomes more important in this kind of repetitive task projects. So these are some references that I've taken. That's it from my side. So if you have any doubts, you can unmute and you can ask. Yes, thank you. And yeah, if you have any doubts, you can ask. Yeah, participants. Thank you, sir. Let me share the attendance link once again.